What do you want to learn?
Something new.
Something new. We are in week 10. You probably already know that. So this is just our little preamble where I kind of go over what you should be doing. You should be through all of week 10 assignments, right? So week 10, Visual Basic Mood Controller. I'm not a fan of VB at all, but it's written into the curriculum. I got to teach you something about VB. So here's a little VB assignment. It's pretty straightforward, pretty easy. If you're at home and you can't download the software, this link to the software might be updated since I put that in there. So just Google it, Visual Studio Express, Visual Studio Express, right? And let's see what comes up. Download Community, new edition available. Community 2015, Express for desktop, Express for Windows. Desktop application, this one right here, that'd be fine. Express for desktop. And yeah, make sure you're making a Visual Basic application, not C# or something like that. And so that'll be one of your assignments this week. I've taken out a lot of the programming assignments. Then in week 12, 2 more weeks, there's a little bit more programming in JavaScript. So 13, 14, 15, 16, 17, 18 for JavaScript programming. How many people are like fed up, done? I hate the HTML, CSS stuff. It's too hard for me. 2 people? How many people? 3? 3? Really? You? You're hanging out with the programmer guys. You don't know them? They're not your friends? Really? I don't believe you. You know them?
Yeah.
But you're not into programming like them. Okay. So 3 people. How many people are like, I'm enjoying learning about coding. This is kind of cool. It's a pain, but thank you for making me do it. All right. So I'll maybe give me your thoughts at the end of class whether or not to leave the JavaScript in or not. Or maybe what I'll do is I'll just leave in 3 weeks of JavaScript. So I'll get rid of 16, 17, 18. That'll give you 4 weeks. That'll give you 12, 13, and 14, and 15. I'll get rid of 16, 17, 18 because those get a little bit more hard. I'll just give you some basic JavaScript. That's what I'll do. All right, so that's the VB is your homework for this week. And then, of course, make sure you're doing the extra credit. If you're in my online class, make sure you're posting to the discussion board for this week's discussion. And then in my T-Lab, you need to, we're in week 10, so that's week 1. That was through week 5. That was through week 9. Right? And this is week 10, the first access one. So you should finish up. Office lab test for Excel. So Word and Excel should be done, those 2, Office lab tests. You should also, just for hoots and hollers and kicks and giggles, you should go into extra credit and take the final exam in this Udemy training, Excel training right here. And if you get like a 70 or above, I'll give you 5% extra credit. So now that you know something about Excel, and if you don't, go through that training a little bit until you figure those things out. But all you got to do is take the final exam in there. It's the last quiz. And send me a screenshot of that in Blackboard here, and I'll give you extra credit. So it's a little bit more involved than what we've learned. So that should be done. And you should also do the chapter quizzes through 10. So that's what you need to do. All right. What did you guys think about privacy and security last week? How many people like talking about that? How many people did not just ask their side of the question? Really? Interesting. How come? Just like, I just want the code. Don't show me sociology stuff. How do we keep ourselves safe in this new day and age, right? So we talked about some of those things, but let's specifically talk about keeping ourselves safe. So how do we keep ourselves safe? And that's, kind of one of the things on the docket, protecting yourself. How do you protect yourself? What are some things that might harm you? Identity theft? Companies not hiring you or schools not letting you in because you look like a dork on Facebook or you tweeted something bad about your boss and your boss read it. Common sense stuff, right? But just be aware of the transparency of our world, that if you're on a computer, basically people are working as hard as they can to get access to the information about you. And that information is for marketing, right? So what you're doing, or if you're searching, people know, that sounds kind of vague, but like the NSA, right? Maybe the search engine knows what you're searching for. Maybe it's associated with your account, right? You send an email, not necessarily private. Can't count on it being private. So you just need to be aware of that. Like, don't send social security numbers through email. Don't send, bank account information through email. Like, tax time comes and I have some people saying, send me your 1099 via email. That's not encrypted. Anybody could grab it. Whatever. Here you go. Right. And then HTTPS, right? That means that everything you transmit is secure. So if you're at some site and it's asking for your credit card or bank account information, make sure it's HTTPS. You know what I mean when I say HTTPS? It's this up here, right? HTTPS. That means everything between the sender and the receiver is encrypted, so it's hard to break. How else do you protect yourself from identity theft? So just be careful sharing personal information. Who you share it with. What's sensitive personal information? Birth date. Like I just filled out a form today, and it's like, what was the birth date of your son? I'll tell you his birth year. And to hell with you, you're not getting his birth date. But that's close enough, right? Here's his birth year. I don't want his birth date out there. That's critical information. So I didn't give it to him.
Because of the month, and date.
You know to crack my Blackboard account. Blackboard's the easiest thing to break in the world. You could all hack your A's instantly, right? Like if I'm logged out of Blackboard, crap, is there anything else I want to show you? If I have a Mac and a Windows and I don't have access for the program access for either, is there an alternative to use? You can use the computers on campus. There we go. All right, log out. Easiest hack in the world right here. Initial password. If you have not changed your password, initial password is uppercase, lowercase, birth date. You know how many people probably not changed their initial password? Faculty included? Most. Probably most. So all you got to know is my birthday. And I think I probably strolled in here and said, hey, it's my birthday.
Not yet.
Not yet. But how hard would it be to find out Todd McLeod's birthday?
Not looking up.
Happy February 18th birthday to Tammy and Todd. What the hell? All right, let's try that. What year? I don't know. He looks pretty old. 1960? Nobody even batted an eye. You guys suck. I better go change my password. So, personal information. Change your password. Make sure that you are not a computer. Domain, students, username. Old password, filled it in for me. New password. I don't know. What should I call it? Password 1, 2, 3. I think that's a good one. Huh? I don't know. I'll worry about it later. GDG, she says. So, keeping information private. I'm just looking to see who's typing to see if they could get into my Blackboard account.
And choose their group.
Hey, I'm done with this class. High stakes game to do that though, because you're breaking the law at that point. What else do you need to do to protect yourself? Social Security number, mother's maiden name, all that stuff. That's personal, private. Never click a link in an email. You get an email. So you don't see phishing so much, especially if you're using Gmail. Maybe if you're using Yahoo, you still see it, but don't click links in email. One of the greatest security risks if you run a company is your employees. That's where companies get hacked or whatever, lose information from previous employees. Just looking. So you want to have a secure password. Anybody in here use like a password generator or a password bank? Tell us about that. Which one do you use?
I guess the main one that everyone uses is 1Password.
1Password, I don't know. Is that like an iPhone app?
Yeah, it's an app.
And then what do? You just
You just put like how many characters you want, how many like you choose how many numbers you want, how many letters, and then just generate them and come up with like
and then it just stores them all. So when you go to that place, it puts it in for you. What happens if somebody gets your phone?
I think it's stored on the 64-digit, so that way it's like out in the cloud, it's like stored on the phone. So like you need a master password to get into the actual app.
To put in all your passwords.
Yeah. But like I don't want to get to like the login, so I just have it on there and then just like write it down and then type it in myself.
Wow, that's a lot. So if you make up your own password, you want to have it be long, and you don't want to use like pets or kids' names, or it's just random stuff. So just create some random string for a long password and just memorize it. But then to do that for every website, that's hard, huh? So let's see, Mac. You might also do this for Windows. Mac Password Manager. Mac Password Manager is Macworld. The best password managers, Keeper Password Manager, and Digital Vault. But you gotta ask yourself, who made it? So you can look up password managers like we were just talking about. Or create your own. One of the main ways that people do hack is through social. What do they call it? Social engineering. Thank you. Social engineering. And social engineering is just to get somebody to give you the information or give you access. So it could be that you get a phone call at night from Microsoft or from your bank, and they're really concerned that there's a little bit of security hole, but they're going to help you take care of it, or yet your computer. Let me walk you through it. Please go here, go to that website, now download this and install it. Okay, everything looks good, safe. All right, thank you for your time. You're protected now. No, you're not. You just gave somebody access, right? So if you ever get a call from Microsoft or your bank, cool. What's your number? What's your name? Let me call you back. Hang up, and then look your bank's phone number up online. So just be like, Bank of America customer service or whatever. And you give them a call and you say, hey, I just got a call from this guy at this number saying I have a problem. Is there anything wrong with my account? Right? You call them, don't let them call you. And you know who you're calling as opposed to you don't know who's calling you. They could say they're anybody. So social engineering, you might even have somebody show up in person. New guy, IT, I'm here to help you. Oh, okay. Malware, spyware, viruses. So virus sticks, that's what my friend calls USB sticks. That's like one of the big ways for hacking is to just there's this really great video on YouTube. 60 minutes Stuxnet. Stuxnet, computer worm opens up new era of warfare. Right? So what is a computer worm? How's a worm different than a virus? How is a worm or a virus different from malware, or are they? So when you hear those phrases, malware, the prefix mal stands for what? Bad. Malicious. Malevolent. Malware. What's another mal? Malnourished? Malpractice? Yeah, so we were choosing names for our kids. I was like, we can't name our kid Malachi. It's like bad Kai. You know? It's like I rule out certain names just because, like, if you know the etymology, is that the right word?
Yeah.
Is etymology the sort of makeup of a word? If you know about that stuff, you're like, that doesn't seem like a good idea to name your kid that. Hopefully there's no Malachi in here. You're like, don't worry, you're in good company or maybe bad company. My parents named me Odd. Oh, why would you name me Odd? We didn't. We named you Todd. Yeah, it was pretty much all my whole life. Everybody's been saying, hey, what's up, Odd? Call me Odd my whole life. I don't think it's a good name. Not a fan of my own name. Anybody else not a fan of your own name? You guys all like your names? So malware is just malicious software. That encompasses viruses. A virus is just another way to say malware. Viruses usually get passed from user to user to user, just like we'll pass a flu or a cold virus from user to user to user, right? Like I have the cold, I give it to you, you give it to somebody else. I have the virus, I give it to you, you give it to somebody else. So that's the idea behind a virus. A worm is like a piece of software that gets put into a system and could just sort of find its way through the system, navigates through the system. So Stuxnet was a computer virus worm, which nobody knows who made it, but most people say America and what's that place in the Middle East that people get all the promised land?
Jerusalem.
Jerusalem, thank you. Yeah, that America and Jerusalem put it together to attack Iran. And Iran was trying to create, refine uranium to get it pure enough for nuclear bombs or whatever the heck they do for that. And so they had, secret facilities, and America wanted to sabotage their facilities. So do we send missiles in to blow up their facilities? No. What they did is they created some software. The software targeted, they knew what hardware, what machines were running the centrifuges. They were Siemens control boxes. And so they wrote software to target Siemens control boxes. And the software that they wrote said, increase the speed of the centrifuge, but report back that everything's normal. And so the centrifuges would go fast and burn themselves out, but the operators are like, everything's normal. It's reporting normal, right? And so how do you get it into a secure facility? First of all, if you're building that facility, how do you make it secure? You don't connect it to the internet. Like if you have computers inside, no external connections. Step one. So nothing's getting through on a wire into our system, right? And then you just have physical outdoor perimeter security, barbed wire fences, guards, things like that. Well, how do you get a piece of software into that type of a system? You figure out who the engineers are and where they live and what coffee shops they go to. And then you see, okay, look at that engineer there. He goes to this coffee shop every morning. And you get like a 32 gigabyte flash drive, and you put a few pictures on it of people, like just normal, whatever, living their life. A few files, like Word documents, or something innocuous. You leave it in the coffee shop right before that guy comes in at the coffee table he always sits at. And then he sits down, finds his flash drive. Whose is it? Sticks it in his computer, sees pictures, sees documents, can't figure out who it belongs to. He reformats it, takes it to work. Well, embedded deeply in there, beneath where reformatting is that piece of code. He plugs it in at work, and then the code is is designed to whatever it gets plugged into to go into that system. Cool. Right. That's how people speculate Stuxnet got into the Iranian nuclear uranium refining facilities. And they also broke during the early parts of the Gulf War. The U.S. military had their signal intelligence people. That was compromised in a similar fashion. So now it's a security policy. You can't bring in any external flash drives at a lot of places. So that's kind of interesting. When I was in China, they were selling flash drives, large volumes, really cheap. So I bought one and stuck it in my computer, and it's weird. It didn't work right? So I just reformatted my computer after that. Like, I don't know what I just put on my computer. Or one of the ways that America got hacked was we gave root access. We gave access to a consultant in China to some of our really important servers, and then he copied all these documents and gave them to the Chinese government. It's like, well, you shouldn't have given that guy access, but we hired him as a consultant, And then he's like, I live in China. I'm taking all this stuff. I'm giving it to the Chinese. So that's just malware, spyware, viruses. Spyware is software that spies on you. So it could be as simple as tracking cookies, or could be as could be like keystroke capturing software that's always running and sending back everything you type. So you want to run antivirus software on your computer. It's another way you protect yourself. If you're on Windows, if you're on Mac, you could Google do I need antivirus for Mac? And articles say yes, no. Most of them say no. You don't need it because Macs are much more secure, just the way they're built. And so I don't have antivirus software running on my Mac. I don't know about Unix. Anybody know about Unix? I'm asking you too. And then you just have to protect yourself from yourself, right? And protect those around you, just in terms of what you expose yourself to, because there's a lot of wacky stuff on the internet. So if you have kids in the house, you want to talk to them about what's appropriate, not appropriate, and keep your keep computers that they're going to use, kids are going to use, in public locations, so you can monitor what are they looking at, who are they talking to. But just talk to your kids about what's safe, what's not safe, and not revealing information, not talking to strangers online, not giving out personal information like your address, and so that's just common sense. Making sure you update your operating system. Securing Wi-Fi, we already talked about this briefly when we talked about networks. Anybody need to hear anything about it again? Those are the steps. How you secure Wi-Fi. So when you build an authentication system, there's 3 ways that you could sort of check somebody's credentials. You check who they are, what they know, what they have, and who they are. You can check those 3 things. What they know, what they have, who they are. So how's an ATM do it? It's what you have and what you know, right? You have your ATM card and you have a PIN. How does your card do it? What you have, right? Some people, it's what you know. Some of those cards have a little key. You can punch in the code on the outside. You don't see that as much anymore. But if you locked your keys in your car, you can punch in the code and then get into your car. Does anybody have a who you are authentication? Some device that authenticates based on who you are, biometrics. Anybody have one of those iPhones where it takes your thumbprint?
My
Yeah.
laptop.
Your laptop
Takes a picture of my face.
takes a picture of your face,
Yeah.
and if it's not
That's
you,
why
it's like,
I
this isn't
show my
you.
face and I log in.
That's
Pretty
cool. So that's what you have, what you know, who you are. Kind of cool just to realize those are the 3 ways that you could. And the more of those you add in, the more secure you make it. Anybody interested in how encryption works? So here's basic encryption. It's a Caesar cipher. So this is rotating 13 letters in the alphabet. So here, if we're at H, we rotate 13 letters and we get U. So if you count H to U, that's 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right, halfway through the alphabet. 26 characters in the alphabet. So that's, you'd send over URYYB, and that's encrypted. Well, the person who receives that has to know what?
Hit code.
Has to know how it's encrypted to be able to unencrypt it. And so that's symmetric encryption, meaning the way it's encrypted and the way it's unencrypted are exactly the same, symmetric. You know, and so you sometimes will hear about symmetric key encryption. Symmetric key, same key to encrypt as to unencrypt, which is just to rotate 13. Asymmetric encryption is the way I encrypt it and the way it gets unencrypted are two different keys, or two different methods. So I might encrypt it with rotate 13, but then to unencrypt it, you might need to do something else. And then the algorithm, right, figures out how to crunch it. You use some sort of algorithm to crunch it, to encrypt and unencrypt. And so sometimes I might have a private key which encrypts it, and then I could give out public keys to people. And if you have a public key, you could unencrypt it. And with the public key, you could encrypt things and send it back to me, and I could unencrypt them. So private public key encryption. It's kind of interesting. So it's just kind of like black boxes. There's all kinds of different encryption algorithms that are out there.
So you have to know this algorithm to crack the codes and like in a war, they crack the
Yeah, so like, you know, in web programming, I could show you some encryption. So here's this is a good one here. So right here is a SHA-256 checksum. So if I download this software for Apple, I'm downloading it right now, and I launch my terminal, and I could Google SHA-256 Mac, how to generate SHA-256 checksum. Uh, 256. SHA-SUM A256, and then the file. I wonder what the A does. SHA-SUM A256. There we go. A. Algorithm. SHA-SUM A. Printer check SHA. SHA-SUM A. That's cool. So here I would go to downloads. I could list that, and I just downloaded the Go 1.6. I could do SHA-SUM A 256 and then Go. And then it just gave me that crazy big number. CAB F5C. And if I look here, let me see if I could find it. CAB F5C. So I downloaded that file and then I ran the SHA-SUM checksum against that. What did that tell me? So the SHA-SUM is a little algorithm that you put stuff into and it will produce a result. And if I put in that file and I get this, I've received the file that was intended. So they created this file, and then they ran all of the zeros and ones of that file through an algorithm, the SHA-256 algorithm, and it produced that number. I download that file, and I run all those zeros and ones of that file through that same algorithm, and if I produce the same number, then what they intended is what I received. If I produce a different number, then the zeros and ones I received is different than what they intended. So maybe somebody got in the middle and tried to give me a different piece of software. So that's a way for me to check, just make sure what I received is what is intended. And you could do other stuff, you know, like going web. Just looking for an example. So here is SHA-256, and I could pass in a certain key to keep it private. So anybody can run SHA-256, but I'm adding in some salt. I'm salting the algorithm, and it's a key which gets thrown into the algorithm and then creates a new code. So if I pass in test@example.com, right, I get that code right there, 45315, and that's built off of test. If I change one character, let's make it test2, and I run that again, I get a completely different code. Just one character changed. So I could use that if I'm creating a web application. So here's a little web application. So I'm just going to put in test example. So test example, like if I write this cookie, and I'm a server and I write that cookie and I store tested example in the cookie, and then somebody, and then when somebody comes back to my web page, they send that cookie with it. That's the way cookies work. How do I know that they didn't change this value on their computer? Well, I could have that thing where I run it through the SHA-256, and I could check to see the value there. If this that they gave me is the same as the value I calculated it when I sent it to them, because they're sending this back to me, and they won't know how to calculate that value because it has the secret salt in it, right? If it's different, then I know they tampered with the cookie. That's hash-based message authentication code. Kind of interesting. So encryption is just taking something and running it through a black box to get a certain output. And then being able to unencrypt it if you want to unencrypt it. So you can encrypt things one way and you never be able to undo them, but it tells you something. Or you can unencrypt things too. Anybody find that interesting? All right, so piracy is stealing things, right? Pirates steal things. So software piracy is obviously stealing software. Or MP3s, or movies, or BitTorrent. How many people BitTorrent in here? Nobody? There's one person. The programmers. Because you could also share legal files through BitTorrent. That's what you do, correct? Right? But through BitTorrent, you could download all kinds of stuff illegally. But that's software piracy. Carries a penalty. All right, anybody have any questions? Did you learn something new? How many people learned something new? What'd you learn? That's a value. What'd you learn that's a value? I rambled for like 40 minutes, right?
About privacy, about encryption.
Privacy, encryption.
Computer security.
Hmm?
Security.
All right, you guys have the rest of class to work. Let me know if you need help.